Good morning, everybody. Welcome to the session, Tooling and DevOps for the Hybrid Cloud with Azure and Azure Stack. We apologize for the delay getting started. We had some cases of it worked on my box and nobody else's. So we'll go ahead and get started. My name is Anjay Ajoda. My co-presenter today is Michaela.
Hi.
We're both program managers on the Azure Stack team on the developer experiences team. So we'll go ahead and get started. How many of y'all attended Ricardo's session yesterday on hybrid app patterns? Okay, cool. So how many of y'all know what Azure Stack is? Raise hands. Also great. For those of you who don't, you'll get an introduction today. So first of all, Azure is the premier cloud environment. We're productive. We have lots of new services with new ones being introduced every day. We're the only consistent hybrid cloud with a consistent API surface between both the public cloud and on-premise sides. We're intelligent. We have lots of new APIs regarding and services around cognitive services, machine vision, translation, and we're trusted. We are the most certified public cloud and the most certified private cloud. Again, we're talking about the hybrid point. We are the only consistent hybrid cloud. We have a common identity between Azure Public and Azure Stack. You can authenticate with Azure Stack using Azure Active Directory just like you would with Azure, or you can federate with your organization's currently existing directory system using Active Directory Federation Services, or ADFS. We have a consistent data platform. We have all of the Azure data services, which include Cosmos DB with its NoSQL, SQL, and Graph database options. And on Azure Stack and in the regular on-premises environments, we have the power of SQL Server along with a few other database providers. And the thing that makes Azure and Azure Stack really special is that we have a unified development environment. The same knowledge and skills that you have gained working on Azure apply directly to Azure Stack. There might be a few new things you have to learn, but 90% of what you've practiced over the years developing for Azure will work on the on-premises environment in Azure Stack. And we have a very consistent security and management posture. We have Azure Security Center and Azure Resource Manager tie into Azure Stack, and our on-premises infrastructure is as hardened as is the public cloud. Again, when we talk about Azure Stack, we want you as developers to think about it as an extension of Azure. It's not this little cousin off in the corner. It's ignored all the time and then taken out at family reunions. No, it's a first-class citizen. We treat it just like Azure. We're in the Azure development meetings. We're part of the Azure roadmap. We are absolutely consistent and part of the Azure family. Azure Stack fills a fairly big but unique niche in the cloud computing and public computing environment. We have 42 Azure regions across the world. That's a huge number. That's football fields upon football fields of data center space. How many of you here are not from the United States? Okay, so this is American football, not the other one. And we have hundreds of service providers that we think will offer Azure Stack. So say you don't work for a large enterprise, but you still want access to a private cloud environment, and you may not be able, for whatever reason, maybe you don't live near an Azure region. You want to use the Azure platform. You have service providers that will offer you space on their Azure Stack installations. And then for those of you who want to run your entire cloud, we believe that thousands of enterprises will run Azure Stack in their data centers to provide a consistent model that the developers already know from the public cloud. The Azure Stack promise is that you get a consistent development environment, that your skills transfer from public to private cloud and vice versa, and that we make Azure services available on premises. Now, Azure Stack is always going to follow Azure. I mean, we use Azure as a testing ground and proving ground for lots of new services before they become generally available. But once those services are proven out in Azure, they'll come to Azure Stack. And we have an integrated delivery experience. We want to make sure that the same support experience that you've come to know and love about Azure is the same support experience you're going to get on premises. This means that when you file it, so Azure Stack is sold as a hardware and software offering. Hardware is purchased from a vendor. The software comes from Microsoft. But when something goes wrong, you don't have to file 2 tickets. You don't have to talk to 2 different people. You don't have to, get us all together on a conference call and say, someone fix this or so help me. You file 1 ticket, and Microsoft and the hardware vendors manage the entire support process for you. That's it. We believe that Azure Stack has a number of use cases where it especially shines. And in fact, we very fervently believe that Azure and Azure Stack work better together. You shouldn't have one without the other. And in cases, so we have 3 different cases where we think this works really well. We have edge and disconnected solutions. Say, how many of your organizations do manufacturing or someplace that requires lots of land and space? All right, I see you. Your factory probably doesn't have the best internet connection. It's probably out somewhere where land is cheap and internet connections aren't the best. But you still want those real-time insights and analytics about how your processes are doing, and to make sure that an on-site team can make adjustments and changes and make sure that you're running the most efficient operation possible. This allows you to bring the power of the insights you'd use in the public cloud to an environment where there may not be a reliable internet connection. Maybe you're out at sea on a ship. Maybe you're on an oil rig. Maybe you're at a construction site. All these situations are where we think Azure Stack and Azure shine together. Sometimes you have lots of regulations. Azure and Azure Stack are the most certified clouds, but maybe your organization says, no, we're not putting any data in the public cloud. Or we're not putting, say, identification numbers or credit card data in the public cloud. Or there's a law or regulation saying that data can't leave the boundaries of the country in which it's created or stored. Again, Azure Stack allows you to get the power of the cloud that you know and that you love and that you want to use, but within those regulatory boundaries. And the big one, the one that we think really enables the other 2, is that we bring the cloud application model on premises. You're cloud developers. You're used to deploying all the time. You're used to automated development processes. You're used to being able to iterate at any speed you choose. This model brings that, Azure Stack brings those benefits onto the on-premises environment. Here's what we've got for you today and in the near future. We have PaaS services available and IaaS services. We have Azure App Services along with Azure Functions, which is great for serverless computing and rapid data processing. We're working on bringing out, in fact, we just announced previews of Service Fabric for Azure Stack and Kubernetes clusters for Azure Stack. This isn't the managed Kubernetes offering, but the ability to automatically create a Kubernetes cluster that you would maintain. And Pivotal just announced that Cloud Foundry is going to support Azure Stack fully in its next release. And we also have the standard suite of Azure IaaS services. We have virtual machines and virtual scale sets. We treat Linux as a first-class citizen, just like Azure does. We have the ability to provision Docker containers on those VMs automatically. We have a number of networking resources. You have your virtual networks, network security groups, your load balancers, and your VPN gateways. And storage, we have blobs, tables, and queues, the consistent Azure Storage APIs that you're used to. And we have Key Vault for protecting your application's keys and secrets. The biggest part about Azure, the biggest benefit of Azure, or one of the biggest benefits, or else the other people are going to be very unhappy with me, is that we have a great ecosystem. We've worked with vendors all across the tech industry spectrum, from those who have been longtime Windows shops to those who are dabbling in Linux and everything in between. And we want to make sure that whatever we say works on Azure, that's part of the Azure Marketplace, works on Azure Stack. And in fact, we've built a pipeline that Michaela is going to show you that brings some parts of the Azure Marketplace onto Azure Stack, and they deploy from the Marketplace like you're used to. But here's, again, where we really shine. That same thing where we have the big ecosystem of applications and solutions that run on Azure and Azure Stack, we want to do the same thing for your applications. We want to build a consistent development environment so that you can build and deploy apps the same way for any Azure cloud, be it public, be it private, be it an Azure sovereign cloud like Azure Germany, Azure China, or Azure Government. We want you to be able to use the same developer tools such as the CLI, PowerShell, and the different SDKs across Azure and Azure Stack without having to rip out and refactor your code every time you want to switch clouds. And we also want you to be able to rapidly iterate and bring those features and ideas that you have in your head directly to your customers with common DevOps practices across Azure and Azure Stack. This means that when you fire up, no matter what it is, Visual Studio Team Services, Jenkins, Travis, pick your poison. We want you to be able to use it wherever you want to use it, and you don't have to change anything about it. Let's talk about hybrid cloud tooling. How can I connect and develop for the hybrid cloud? The secret sauce, or the not-so-secret sauce, behind every Azure cloud, whether the public, sovereign, or private cloud, is Azure Resource Manager. How many of you have written an ARM template before? Perfect. All right. So Azure Resource Manager allows you to organize different resources, say virtual machines, network devices, and storage accounts in logical ways that make sense to you. Do you want your app to be separated by tier? Is that how you normally run your deployments? Great. You can put everything in a resource group per tier. Or maybe you like to do things in vertical slices. You can organize it that way too. It allows you to incrementally update your applications. So rather than me having to wipe and redeploy an entire fleet of servers because I changed one thing or I opened a port or something, I don't know, you can just submit a new deployment. ARM automatically calculates the changes and applies them. ARM manages every Azure and Azure Stack service. In every cloud installation, there's ARM in front of it, providing a gateway that manages your quotas, it manages access, it manages subscriptions, all of that. You've seen the Azure portal, all of that's backed by Azure Resource Manager. Again, it runs in the cloud and on premises, and you use ARM templates, which are JSON documents to describe deployments. ARM in the hybrid cloud. Again, Azure Stack follows Azure. You need to be able to know, you have different resource providers, say Microsoft.compute for virtual machines, Microsoft.network for load balancers, and they have different API versions as those teams push out new code. Azure Stack is always going to follow a little bit behind because we want to prove things out in Azure before bringing it to the private cloud. This means that when you develop for the hybrid cloud, you'd have to keep track of your different SDK versions. Which SDK supports this API version, and which API versions does the Azure Stack I'm targeting have? You have endpoints and locations that change across clouds. Azure Stack deployments have the ability to change their region name. They can make their region my basement, or my data center, or Stockholm. Pick it. And you have to manage service principals. Service principals are service accounts that allow you to log in programmatically to Azure Resource Manager. This all gets a little unwieldy. How do we fix it? We've come up with a concept we called Azure Resource Manager API profiles. These are a set of namespaces and API versions that are tied together. So all you have to know is the name of the profile, and you get access to a list of API versions. This allows us to make sure that template and tooling is compatible across Azure and Azure Stack. We're working to make sure that all of our tooling, be it command line, scripting, or SDKs, can accept the profile and then automatically version the SDKs and the requests they use to match that. Developers should start coupling their code to profiles rather than different SDK versions or API versions. We release 4 profiles per year. This is the name. These are the profile types. We have latest. It's going to be the most recent API version of anything that's released in Azure. You have profile. Latest is the cutting edge. It probably won't work on Azure Stack. We have profile. This is cut every few months, and it's just a snapshot of the API versions in time in Azure. And if you want to target hybrid clouds and hybrid deployments, we have -hybrid. Again, these are all year, day, month, or year, month, day, and then this identifier, except for latest, which is always just latest. That's released 2 times a year, and it's guaranteed to work on a fully updated Azure Stack. here are the current profile versions. First, we have latest, then we have 2017-0309 profile, and 2018-0301 hybrid. That one's not entirely out yet, but it'll be coming in the future weeks, the hybrid one. Let's take a look at how profiles can ease our development process. Hold on, my VPN is acting funny. All right. So as you can see, I have Visual Studio Code. Visual Studio Code's a great way to edit ARM templates if you haven't tried it. It allows for diffing, searching, and it's Git compatible. Remember, ARM templates are text. They can be checked in and versioned just like you would actual code. So right now, I have just a simple ARM template that deploys a storage account. If you look down here on the left, this is before profiles. In every resource, I would have to put an API version block and an API version value and the API version for that particular resource provider. In this case, it's 2016-0101. But I have to remember that for every single resource storage provider. And for something like a virtual machine or a web application that relies on load balancers, network interfaces, public IPs, and the VM itself, as well as storage, that can get unwieldy. So then we have this. Let's look at the top here. It just says API profile 2017-0309 profile. That's it. That's the entire thing that describes the API versions for every resource listed in that ARM template. There's no need to remember which one is for which resource. There's no need to remember which API versions are on that particular cloud that I'm using. It's which profile does it use? Easy. And you just have to enter it once. It deploys the same way and works the same way. That's it. Let's go ahead and go back. Let's look at Azure scripting and tooling. Again, you notice this entire time I've said Azure and not Azure Stack scripting and tooling. This is because these tools are the Azure tools. You don't need to look up Azure SDK and then Azure Stack SDK. You just look up Azure SDK, get that, and get started. The Azure CLI is a cross-platform instance that supports API profiles, connects to Azure Stack, and runs, of course, on Windows, Mac, and Linux. It's Python-based. But it does require valid certificates to be imported. For those of you who are using development or test deployments of Azure Stack, this can be a little hairy. But we provide instructions on how to import the correct certificates. We have Azure PowerShell, which also supports API profiles and supports authentication to Azure Stack. And we have several PowerShell modules on GitHub that are designed to help you get started with Azure. We have ones that help you connect to Azure Stack. We have ones that help you add virtual machine images. We have ones that can help you test it to make sure installation went correctly. And that help you get started and manage your Azure Stack installation. Let's take a look at how PowerShell works with API profiles. OK, let me zoom in here. Much better. If you look up here, you'll see that I have run some scripts that say,
You're not on the screen.
oh, sorry, thank you. Forget I have to push the button. So I installed module Azure RM Bootstrapper. That says, let me get the things required to install a particular profile. Once that's done, I put use Azure RM profile and then the profile name. At that point, it installs the correct version of the Azure commandlets for every single resource that is available in that profile. This will take some time. And then I just simply install the module that's Azure Stack that allows us to manage the administrative parts of Azure Stack. That's it. That's how you load the latest profile into PowerShell. It's fairly simple. Now we have the Azure SDKs. Again, Azure SDK, not Azure Stack SDK. We're updating every Azure SDK to make sure they support profiles and are compatible with Azure Stack. Right now, we've got preview versions of the Go SDK, the Python SDK, and the Ruby SDK. The Ruby SDK is itself in preview, so expect some breaking changes. In development, we have the Java and .NET SDKs that will be coming at a later time. But I do have a little preview of something for the .NET SDK. Our goal is that all Azure SDKs will support profiles and be compatible across clouds. Let's take a look at these SDKs. First, we'll look at Go. It's a very simple Go package. If you look here though, let me just zoom in. The way I implement, how many of you are familiar with Go? Okay. So the way I vendor and import these resources is I say import the Azure SDK for that particular profile and for that particular module. In this case, resources for Resource Manager. And then I say import the next profile version for the storage, because this is a program that creates a storage account. And then I import AutoRest and ADAL to make sure that I can authenticate to Azure and Azure Stack. In all of these demos, you're going to see that I use what's called a service principal. It's an application that you create through the portal, and I'll demonstrate that later, in Azure, and it's got a tenant ID, which is your directory tenant, and it's usually something like microsoft.onmicrosoft.com, or in this case, fabricamhostingco.onmicrosoft.com. It's what all of your user accounts come from. That service principal has what's basically a username, a client ID, and a password, a client secret. And for those of you who are going to go and try to run up my cloud bill, I'm disabling it after this session. So please, you can try, it won't get very far. And there's a directory audience, the Azure Stack subscription ID, the Azure Stack management URI. This is the location of the Azure Resource Management endpoint in Azure Stack. If I was pointing this towards Azure, I'd put the Azure endpoint, management.azure.com. And this will change depending on your Azure Stack installation. And the Azure Stack region name, local. First, I create a new service principal token and we have functions built in that call the endpoints API, which tells each particular SDK which graph endpoints to use and which login endpoints to use to properly authenticate with a particular cloud in question. At which point, I simply follow the normal Go methodology for creating a storage account. I create a storage account, I pass the parameters, I let it run. Let me just move this. And then view the terminal. I can just see. And then let me just go ahead and go. As you can see, I can barely spell sometimes. Okay. And you'll see that it's created it. And we can go and look at the Azure Stack portal. And we can see that I have a new resource group. And in time, I will have a new storage account. Go demo storage, easy as pie, and the same code will work on Azure because I've given it a profile that I know works across my consistent clouds. Next, we have Python. How many of you are familiar with Python? Okay. So in Python, you generally import different modules from a particular source, and it's very similar to C# in this way. Again, I have my location name, I have the resource group name, I have the storage account name, and I have that same service principal string again. I have a tenant ID for my directory. I have a client ID for my service principal. I have a client secret for my service principal. I have a subscription ID in Azure Stack, and I have the endpoint for Azure Resource Manager in this particular Azure Stack. Again, I call the endpoint ID to define, so first I define a known profile. As you can see here, it says known profiles use v2017-0309. That's the same profile I used in the last example. And we know that it's going to work across Azure and Azure Stack. At which point I create a client for each of the different resource providers I want to access. In this case, Resource Manager for subscriptions and resource groups, and the Storage Manager. And then I'd tell it a base URL to use. This allows me, if I don't include the base URL, it'll default to the public Azure endpoints of management.azure.com. In this case, I've given it a different one of the Azure Stack ARM endpoint, so it'll redirect all requests to that particular endpoint. And if I run it, where's my terminal? Used. Okay. Sorry, there we go. Okay, I know it's running, but I cannot find the window for the life of me. In the meantime, okay, let me go ahead and start a terminal here. 1 second. There we go. Soon I should see a storage account pop up here that is Python based. That's from Python. There we go. I have a new storage account, Python demo storage. Again, it's the same principle. I imported my SDKs, I set the correct profile, I authenticated, I sent the same URL, I sent the management URL for Azure Stack, and then I'm able to create my resources just like I would using the regular Azure, just like using an SDK that targeted public Azure. The same principle applies to Ruby. Again, the Ruby SDK is in preview, so I have my storage account name, tenant ID, client secret, subscription ID, and Azure Resource Manager endpoint. In Ruby, I just tell it as part of each import, Azure Storage with a profile to use, and then create a client based on those different, and then I create a client based on those different resources and those API versions and those profile versions. Again, it's the same process we followed for the last two SDKs, and it applies to every SDK we're introducing in the future. Create a service principal, add your URL, and then create your resources, specify a profile, and create your resources as you normally would. Now the fun one is in .NET. So I'm using Visual Studio, again, my preferred IDE of choice, and you can use yours. So Visual Studio so .NET doesn't have all the profile support just yet, but we have a preview here. What we have in the top, let me zoom in real quick. If you see my using statements, it says Microsoft.Azure.Management.Resource standard, fairly standard, .API 2016-0201. That's an API that I know to be compatible with Azure and Azure Stack. Again, it's not a profile yet, so you still have to remember which API versions you're using, which one you're compatible with. But we're bringing out a way, and this will be released in the near future, a way for you to import whichever particular API version you want with the latest version of the SDK, rather than having to pick an older version of the SDK to get support for a different particular cloud. And the same thing applies for storage. Again, microsoft.azure.management.storage, and the API version I wish to choose. Everything else is fairly standard. Here I can, again, contact the endpoints API. I get the login endpoints and the resource IDs I need. And we follow the same process as we do with the other ones. I create a new credential. I add in a login endpoint. I feed in my I feed in my client ID, my client secret for my service principal, and then I get a token that allows me to operate against that particular cloud's APIs. Again, direct client secret, client ID. I get my token. I'm able to connect to different subscriptions, select my subscription, and create this one down here, and create a storage account as I normally would. Again, I've changed something though. When I create a new resource management client, I say new URI Azure Stack endpoint. That tells that particular client to talk to the Azure Stack endpoint, rather than trying to communicate with the Azure endpoint. If we go ahead and run it, wait for it. Again, you can see we followed the same process, and we're working to make sure that .NET has the full profile support that you will expect in the future. Okay, and then I should have a new resource group. Let's see, .NET Multi API resource group, and it will have a storage account in a little bit, once the portal updates. Okay, the storage account's taking a little bit of time to show up, but again, like I said, I was able to create a new resource group using the same method that we did with all of the other SDKs. So again, the principles are fairly similar. Get the particular SDK, decide which profile you're going to use, and then write your code as normal, substituting a new base URI or management URL for the particular cloud you're targeting. The SDK does everything else, like figuring out how you need to authenticate, what directory application you're using. It takes care of all that for you. It's a lot simpler than it was before. Visual Studio also has some great features. It's a great tool for template authoring, and Cloud Explorer now supports Azure Stack. So in the Visual Studio left-hand pane, I can see resources that run on both public and private cloud subscriptions. And I can easily deploy to any Azure cloud, the same way I would deploy to public Azure. Let's take a look. Visual Studio, it's there. View, Cloud Explorer. Wait for that to open. Okay, that one's taking a little bit longer. Let's try this one. OK, here we go. So as you can see, in my left-hand pane, I have a lot of Azure subscriptions. But some of them run on Azure Stack, and some of them run on Azure. So this one is actually, you'll have to take my word for it, but Azure IoT Stack is running on Azure Stack. But this one over here, the Azure Sponsorship 2, is running on Azure. Again, they both show up in the same menu. They show up, they look identical, and I can interact with both of them like I would any particular Azure subscription in the public cloud. I can see in the one on Azure Stack, it's loading. Let me go ahead and create a new project here, and then, oh, wait, no, and of course, with Visual Studio, I can add in a project that let me use the Azure Stack and Azure Quick Start templates to deploy something rapidly to Azure. So let's look at this in the resource group. And I can choose from the Azure Stack Quick Starts as well as the Azure Quick Starts. These are templates that are provided on GitHub for you to get familiar with ARM templates and to make it easier for you to get started developing your Azure solutions. Just add that one. Right-click, deploy, new. Wait for it to load. What it's doing is it's connecting to every Azure Stack I have access to, which is a large number. So we'll give it a little bit, and we'll come back to that. But I'm able to see any Azure Stack, deploy to it just like I would any particular Azure subscription. Let's take a look at DevOps with Azure and Azure Stack. We all know that software is hard to write. We know that 40% of software gets reworked because it didn't meet what the user wanted. We know that it costs a lot of money to fix issues, up to $100,000 an hour. We know that teams like to say they're agile, but they might not actually be agile. The point being, it's hard to develop software. It leaves developers frustrated. It leaves operations frustrated as to why the software that developers provided isn't working. And the business is frustrated because they can't get new features out to the customers. In a traditional workflow, developers write something, they hand it over to IT or operations who's configured an environment, and sometimes it doesn't work. There's miscommunications, there's emails, there's tickets, there's meetings, and it doesn't work. It's a disaster. It takes forever. Software delivery has lots of frustrations because of inefficiencies in the process. There are delays, and there are lack of insights into what the user is doing and what can make users' lives better. Let's take a look at a traditional on-premises workflow. Developers tell IT exactly what they need for an infrastructure. IT builds it out. They rack and stack hardware. Again, this is on-premises, not in the cloud. Developers commit code to a repository. It's checked automatically or not. It's tested. Then it's deployed to staging, and then the IT and developers go back and forth until someone either quits or they have a semi-working product. This is a pain. Let's look at what happens when we bring the cloud model on-premises with Azure and Azure Stack. Developers write the software and infrastructure code by themselves. It's checked in and versioned into a repository. It's automatically tested, and all the IT person has to do is make sure that the environment and platform it runs on, in this case Azure Stack, is working correctly. They don't have to worry about standing up new hardware and making sure that the hardware is the right size. The infrastructure is defined as code and can be destroyed and rebuilt at will. Here's a list of some common DevOps practices. We'll focus on the first two today: continuous delivery and infrastructure as code. There's a few others like automated testing, deployment, release management, monitoring. There's A/B testing and a few others, but we'll just focus on the first two today: continuous delivery and infrastructure as code. First, continuous delivery begins with continuous integration. You check in code, You trigger a build. If there's an issue, the developer fixes it. If the build succeeds, it goes on to testing. If there's an issue, we repeat the feedback cycle until the developers get it right. But again, this is all automated, except here, where there might be a manual trigger point to make sure that someone knows something new is going into production or staging. Once it's released, we call that release management. We know exactly what bits we have out in the field, and we know exactly what we need to do to make sure, in case something goes wrong, that we can easily recall a build. This entire process is called continuous delivery. How many of you have implemented a DevOps pipeline in your organization? Cool, awesome. That's great to see. That's probably the highest percentage I've seen in a long time. That's good. That means we're doing something right. We're excited to announce that Visual Studio Team Services supports Azure Stack as a native development endpoint for its DevOps build and release steps. This allows you to bring the same automation that you've gotten from Azure to Azure Stack. It works on Azure Active Directory-based deployments today with ADFS support coming. How it works: we use existing Azure build steps with an Azure Stack connection, either with a private build agent or an internet-facing Azure Stack, which requires a service principal and the same credentials for the Azure and Azure Stack deployments. Here's how a hybrid DevOps pipeline works across Visual Studio Team Services and Azure Stack. We check in our code. It's built and published in the cloud using a hosted agent, using .NET Core in this case. We have a private agent, and then it's deployed using a private agent on Azure Stack. This is a virtual machine that's running inside an Azure Stack that connects directly to the Azure Resource Manager, because most Azure Stacks we don't think will be internet-facing. You'll probably have them behind a corporate firewall. Let's look at how to do this. So this is a simple web app. Wait for it. It's a simple default web application you get with a Visual Studio installation, because the content of the application is not the important part. The process is. I commit this code through Visual Studio, and I have a build that's already configured. As you can see, it's a very simple standard hosted build. I run a restore, a build, and a publish. Except here, I specify a runtime, Win10x64. This allows me to specify a self-contained deployment. That way, I know that my application will run anywhere. Ah, yes, see, my website's up. See? These are the engineering leads, Douglas and Tad, who are our VPs, and we're showing this off to them, so it's their hybrid application. At this point, once the build succeeds, there's a release process. As you can see, I'm not perfect, things break, but it all happened automatically, so I don't have to manage it myself. Let's look at this release definition. I have an environment for Azure and Azure Stack, the same identical step in each one. Let's look at the Azure Stack one. I have a hybrid agent that's running on our Redmond environment. That's something that we run internally to make sure things work, that I've configured through a service principal and a personal access token for Visual Studio. And then I'd run the app service deploy step. This is the same step that you have in Azure and Azure Stack, in Azure today. I just told it to point it to a service connection that's pointed to an Azure Stack subscription. using the same credentials and identity as I will with Azure Public. And it deploys it the exact same way. Once the release is done, I'm able to view the web app both in the public and private cloud. I don't think my VPN is letting me show you the private cloud one, but the as you can see, the releases have succeeded, and it was able to deploy the application. Again, it's the same web app running in both clouds, provisioned through an automated DevOps pipeline. Let's talk about infrastructure as code. We have ARM templates. Again, we've gone with ARM templates are just JSON text files that describe a resource. They can be automatically deployed and versioned just like your regular code. That means you can apply the same continuous delivery principles to them. Infrastructure and configuration as code allows you to optimize your resources. Rather than hand building an environment per application, you can take the same environment and size it up and down as will, or destroy it and rebuild it if you mess it up. You can accelerate delivery. You can get new features out faster because you don't have to ask someone to deploy new hardware. And you can measure your efficiency by looking at how fast you can get new features out and your mean time to resolve an error, your MTTR. The same pipeline that we used for Azure and Azure Stack, to deploy that web code, can be used to deploy an ARM template. Again, the process is the same. I check in an ARM template. It's automatically published to a queue. And then I have a hosted agent and a private agent that each deploy it to a resource group in Azure and Azure Stack. Let's go ahead and take a look at those different build steps. So again, you see I have a release here that says deploy ARM template. The build process is simply a copy to a share that both the private agent and the public agent can access. And it's simply a deployment, create resource group deployment. I set the service connection and the name of the resource group and the location, and it deploys automatically. Again, it's the same steps you're used to in Azure. How many of you used these VSTS steps in Azure before? OK, cool. So this should be familiar to you. It's the same steps. You just point it at a different endpoint. And we have lots of documentation on how to properly configure Azure Stack. The entire point of this is to reduce your procurement cycle times and dependencies. There's no need to have someone file a ticket for hardware or get a purchase order. You already have the hardware. It's called your private and public cloud platforms. You just take it, and you can customize it at will, destroy it, rebuild it, as long as you're within your quota, without having to bother the guy running the platform. Everybody's happy. And you have automation and self-service provisioning. This allows you to make sure that you're deploying the application the way you want, and it's automatically tested and built at the same time. The entire point of all these efforts across Azure and Azure Stack to have a consistent development environment that works with all of the Microsoft ecosystem and development tools, no matter what language you're using, is so that we could increase deployment frequency. We have less change lead time from when business wants a change to when it ends up in front of the public. And then we have a smaller change fail rate. How many times do I have to roll something back? How many of you try to sign up for health insurance once a year? Or maybe you want to go shopping on Black Friday and everything breaks because everybody else also wants to go shopping on Black Friday. This allows you to dynamically scale your environment without having to buy that hardware a year in advance. It allows you to make sure that the changes that that company rolled out to support that extra load will work because they've been automatically tested, and there's no need to file a ticket to roll it back if it breaks. You can just do that yourself. And we're shortening the mean time to detect and repair issues, which allows your customers to get better value, the business to be happier, and for IT and developers to stop arguing. And developers, you don't get to say it worked on my box anymore because this is your box. And now I'm going to bring Michaela on stage to talk about the Azure Stack Development Kit.
Thanks. All right. Hi, everyone. So I'm going to talk about Azure Stack Development Kit today. So who is familiar with that? Okay. Everyone used it before? Okay, so it's good that I will point it out that every demo that NJ just showed you today has been built on our Azure Stack Development Kit. So what is Azure Stack Development Kit? Sorry. Okay. I can see on this, sorry. I can see on the screen and, okay. All right, so definitely it's a powerful free tool that you can use for prototyping applications that are consistent across Azure clouds. It's a dev test cloud environment. They're using APIs and tooling that are consistent across Azure and Azure Stack. And also, it's a single node deployment that you can use it for testing all the services that are available in Azure Stack. So why I should use it? Definitely to prototype application, learn and demo, get started with Azure Stack, and prepare your IT teams. So there is a consistent ecosystem along Azure, Azure Stack, and Azure Stack Development Kit. So you can really think that by clicking this green button, you will have all the power of Azure in your data center. And please check out this link. Now that you know what is Azure Stack Development Kit and why should I use it, I'm going to walk through some consideration for you to just before started using it, some deploying tasks, and of course, how we can use it as a tool for prototyping using the same platform of services that are available on Azure Stack. Sorry. Okay. So before you started, those are just considerations. Because it's a single node that you're going to download it in your data center, you have to make sure that your hardware and software meets the minimum requirements. That's in terms of disk, storage, memory, and network. Of course, if you have more memory available, you can use and deploy more services. Everything is well documented here, so please check out this link. In terms of networking consideration, there, of course, ASDK, Azure Stack Development Kit, is a behind the net. But you can also, and it needs a network access to internet. That means that you can also deploy in disconnected scenarios using ADFS. So because it's behind the net, the VPN connection to Azure is not supported through the net. So just please keep in mind this before you want to use it. But why is important Azure Stack Development Kit? Definitely, it has a minimal scale. This is because it's one single node. It's a simple concept, so you can use all the platform of services available in Azure Stack, and there is a consistency between Azure Stack Development Kit, Azure Stack, and Azure. And it's also easy to install. So let me show you how to do this. Yeah. Thank you. All right. So prior to these steps, I'm going to show you, make sure that you reboot your host into the cloud VHDX file. Now we are on it. And the next step we will do is go to this link, github.com, Azure Stack /tools. So those are all PowerShell modules that help you to kickstart the first scenarios, deployment, connection, add default images from the marketplace. So today we're going to use this simple script, ASDK installer, that I already ran it. And what it does is simple show you how to install in just 3 single-step process your ASDK. So let me show you how. So you have identity provider here. So I choose IDFS, but you can also choose others. Then I put my password on it and just click next. So this is just one step. Now I'm gonna select the network adapter. In this case, this one here. And this is the second step completed. And now you can use, of course, your network configuration, DHCP or static IP. I choose static, so I put all my information here. Next. And now, with just 3-step of process, I will be able to deploy my environment and install my Azure Stack Development Kit. This is a summary of our demo. So make sure that you download Azure Stack Development Kit and extract the Cloud VHDX file. Those are the links. You can find it. Run the ASDK installer PowerShell module. And the first time you run it, you have to prepare the host. That means you have to reboot your host into the Cloud VHDX file. Now you log in with the administrator credential, rerun the same PowerShell module, and like I showed you before, you are able in just 3 clicks to install your Azure Stack Development Kit. Okay, now that deployment is succeed, so it will take a few hours. What you should do next? Those are just 4 simple tasks that I'm gonna show you and walk through for you to register with your Azure subscription, populate the marketplace. And this is in particular because we have consistency between Azure Stack Development Kit, Azure Stack, and Azure. By populating Marketplace, we are able to, from Azure, to bring into Azure Stack Development Kit, as you would do in Azure Stack, default images. And of course, because you have the same cloud experience, you can also create offer and plans. And like Andrzej told you before, all the ARM templates are consistent also in our Azure Stack Development Kit, like in Azure and Azure Stack. So it will be easy for you to create your own prototype tools and applications. So let me walk through the first 2 steps, how to register and populate the marketplace. Sorry. I cannot find the environment. Okay. No, it's not this one. Okay. Sorry. All right. Here, just as you can see, just a simple script that you need to use prior to register. So make sure that, first of all, you installed Azure Stack PowerShell modules and download the Azure Stack Tools Resources API profiles. So this is basically here and here. Now you are able to register with your own Azure subscription to your Azure Stack Development Kit. And when you are done with that, it will take just 10 minutes, how you can verify that registration is succeed. You go here to the portal, you log in with your credential, Marketplace Management, and now you can see here that by clicking with this button, you can actually download default images from Azure directly to your Azure Stack Development Kit, as you would do with Azure Stack. So for example, here, there's a list of things you can do. Okay, so I already introduced you a little bit of what are the resources here. And resources are consistent between Azure Stack Development Kit, Azure Stack, and Azure. So Quick Start templates are a repository of GitHub templates. They are consistent between Azure Stack Development Kit and Azure Stack. And we have the latest API version that they are already available in Azure Stack, and then you can use it also in Azure. Azure Stack Tools are PowerShell modules. For example, today we use it, the one to install our Azure Stack Development Kit on our data center. And everything you can look it up on these two links. NJ already showed you what are the Azure tools for deploying any of your platform services, infrastructure services. Those are PowerShell, CLI, Virtual Studio, and VSTS. And also those Azure tools are consistent between Azure, Azure Stack, and Azure Stack Development Kit. So now that I introduce you what is Azure Stack Development Kit, there is a consistent ecosystem between Azure, Azure Stack, and Azure Stack Development Kit. Now you need to understand, and I want to walk through you, that all the platform as services, they are available in Azure Stack, are also available in Azure Stack Development Kit. So there is a unified development across Azure clouds, unified resources, as we saw before, and you have the same experience as a cloud administrator that you would have in Azure Stack integrated system. So because of this, let me show you how to create on top of, for example, app services, and we have many, SQL database, MySQL database, how to create, for example, a function on Azure Stack Development Kit. Okay, I already deploy app services. I create a storage account, and I link the storage account to my function app. Now in my resources here that I created, I can see my storage account, but also that I cannot find anymore. Wait. Ah, okay. Yeah, sorry, wrong resource group. Okay, now I can see my Michaela functions here. I go to function, unless I should restart it. And just, for example, let's create with the default function. So here you can see the API version that I'm using is consistent with the Azure Stack. And by, for example, test, change the name, and I have this output here. Hello, people. So let's go back to the presentation. So what we saw here, Azure Stack Development Kit is fully functional. So you have consistent application development. You have all Azure services available on your data center. It's a minimal scale, so it's just one single node. It's a powerful tool for prototyping and get started with Azure Stack. The limitation is the hardware. You're installing Azure Stack Development Kit on your hardware. You need to reinstall it every time if you want an update. And of course, there are network constraints. So, yeah, I'll pass.
All right, thank you, Michaela.
Thank you.
We're on the home stretch here, so almost there. So now that you've seen the power of Azure and Azure Stack and cloud consistency and the work we're doing to make development across clouds and DevOps across clouds easier, here's how you can get started with the Azure Stack. Develop your applications in Azure. You can validate your applications by downloading the Azure Stack Development Kit, as Michaela showed you. It's super easy, fits on a server. And then once you really love it, you can order some Azure Stack integrated systems for deployment into your customers or your data center. We want you to get started in Azure. We want to make sure your Azure solution works on Azure Stack. We have a number of guardrails on GitHub that'll let you make sure your templates work with Azure or Azure Stack, and will let you constrain an Azure subscription to act like an Azure subscription, Azure Stack subscription. We want you to get started with DevOps and get familiar with DevOps. Azure has a DevOps integrations portal where you can get started and try out your different tools and see how they interact. And then what's next? We want you to look and read about Azure Stack. We have an Azure Stack white paper. We want you to deploy the product, deploy the development kit. It's 3 steps. Michaela showed you. And then once you've got the development kit deployed, deploy some applications from our GitHub. Deploy some ARM templates. Try editing them in Visual Studio and Visual Studio Code. Try out the PaaS services. Try out App Service. Try out some functions. And then once you've kind of got the hang of that, bring your full DevOps and development experience to bear with hybrid apps. We've just published a set of tutorials that will show you how to set up things like the hybrid CI/CD pipeline I showed for both code and infrastructure, to set up a VPN that allows you to bridge Azure and Azure Stack virtual networks, and to make sure you have a consistent identity platform across all your cloud installations. Here we've got some related sessions. These were from previously, if you want to go find them online. And I know the guy in the back is like saying, hurry it up. So again, thank you guys so much for attending. You want to come back over here? Thank you guys so much. Thank you, Michaela, for coming up on stage with me. And please complete your evaluations. There's apparently an Xbox up for grabs, so I would do that. I have one, it's amazing. But yeah, thank you guys so much. You guys have a great rest of the conference.
Thank you.